The floating Earth. The biggest discovery in the pre-scientific era. 100 lessons on modern physics for the next Einstein. Chapter 6. The Philosophical Revolution. Before we look at this question in more detail, let's briefly take a look at the history of early philosophy. This is about the event that we called earlier the Philosophical Revolution. The birth of philosophy. According to the historians, ancient Greek philosophy started in the city-state of Miletus in the Ionian region of Greece, today part of modern-day Turkey, around 6 to 7 centuries BC. Philosophy was born as cosmology in the true sense of the word, because the desire to understand our universe gave birth to philosophy. As we briefly described at the time, we were living in a period when most people across different civilizations had the ancient world view of the flat earth and heaven above, with an absolute sense of up and down. The early development of philosophy, by the first Greek philosophers, was primarily driven by the effort to fix this old cosmological model, and to make a better sense of the world that we lived in. A brief overview of the pre-Socratic philosophy. Greek philosophy went through a big change at the time of Socrates, and it is divided into two periods, the first of which is conventionally called the pre-Socratic period. At the time of Socrates, the main focus of philosophy changed from understanding nature to understanding and prescribing the human behavior, such as ethics, politics, and psychology. The philosophers who were mostly interested in natural philosophy, who generally, but not necessarily, predated Socrates, are now called the pre-Socratic philosophers. We will primarily focus on the work of pre-Socratics in the next few lessons, including Plato and Aristotle. A brief overview of pre-Socratic schools. As I mentioned a few times already, the beginning of Western philosophy is generally attributed to Thales of Miletus and his students like Anaximander and Anaximenes. They are now known as the Milesian school. In addition, there were a few well-known schools or communities, which were largely based on the geographical locations. First, there were the Pythagoreans, which included Pythagoras and Hipparchus, among others. Pythagoras was known to have learned from Anaximander. Second, the Eleatic school headed by Parmenides had a huge impact on the subsequent development of Greek philosophy. Zeno, of the fame of Zeno's paradoxes, was a student of Parmenides. Empedocles and his students, now known as the pluralist, first proposed the four elements, which were later adopted by Plato and Aristotle. And then there were the atomist school headed by Democritus, who first speculated that the material world was made of indivisible atoms. We will also mention Heraclitus of Ephesus in a later lesson, because of the importance of his radical philosophy. Greek philosophy fully blossomed in Athens, and the Athenian school included the most well-known Greek trio, Socrates, Plato, and Aristotle. This was truly the epitome of the ancient Greek philosophy. Ancient Greece. For reference, let's quickly take a look at a map of ancient Greece. First, here's Miletus. Samos and Croton. Pythagoras was born in Samos but mostly worked in Croton in his later days. Ephesus, the city of Heraclitus. Elea, the city of Parmenides and Zeno. Abdera, the city of Democritus. Athens, and we all know Athens, which became the center of Greek philosophy since the time of Socrates and Plato. Chapter 7. The birth of Western philosophy. The Milesian school played a special role in the birth of Western philosophy. Thales of Miletus. As mentioned, Thales from the Ionian city of Miletus is considered the first Western philosopher for many different reasons. First of all, he postulated that the earth floated on the water, for example, the ocean. Thales believed that our entire universe originated from water. Hence, this was a natural view for him. We will briefly go over the philosophy of the Milesian school today, and in the next couple of lessons. By the way, Thales is an English pronunciation. If you want to sound Greek, you can say Thales. It's tomato, and Pythagoras, Pythagoras. The floating Earth. The Earth was thought to have a flat disc-like shape for a long time. Homer was the first person who recorded that in writing. The Earth could not have been infinite in size, since the heavenly bodies rise from the east and set to the west. People were afraid to go too far from home in fear of they might fall off the Earth. Thales postulated that this disc-like Earth was floating on the large mass of water, presumably the ocean, and it was at the center of the heavenly sphere. Although it was floating, the Earth was supposed to stay still because it floated like a heavy piece of wooden log. Thales and Water. This was indeed the first comprehensive cosmological model of our universe. Thales believed that everything ultimately came from water. It appears that Thales had a rather good understanding of water. For example, he seemed to have known that ice, water, and steam are three different manifestations of the same matter, water. Hence, the fact that our Earth floats on the water must have been rather natural to him. About 70% of the surface of the Earth is covered with water, after all. He, for example, attributed occasional earthquakes to the fact that the Earth was floating on the water, for example, due to the large waves. However, Thales did not provide an explanation as to where the water itself floated. Was it turtles all the way down? Despite the incompleteness of his theory, Thales, and more likely his student Anaximander, seemed to provide an answer to the sunrise paradox. Now that the disc-shaped Earth was floating somewhere, the sun would go around below the Earth at night. The sun makes a complete circular motion. So, how did they figure that the sun rotated around the Earth? Again, this idea seems to be attributed to Thales, but it is again largely a speculation. Many ideas from early Greek philosophers ultimately influenced Plato and Aristotle. According to Aristotle, it was Anaximander who first came up with this idea. According to historians, Thales, and more likely Anaximander, divided the heavenly sphere into 5 regions along the longitudinal direction. The stars around the North Star in the first region are always visible, and they rotate around the North Star. You can then extrapolate this observation to the stars that rise and set throughout a day and night, and you can easily guess, by a simple extrapolation, that they also make circular motions even though they are not always visible. Hence, the same with the sun. This is another mystery of the universe. The magic of extrapolation. This is another mystery of the universe. When Newton came up with his inverse square law of gravity, for example, he had very limited data about the sun, the moon, and 5 other planets, mostly based on Greek philosophers and Tycho Brahe and Kepler's observations. And yet his theory, albeit approximate, applies at the scale of millions of times larger. Why? Anaximander of Miletus. While Thales believed that the principal substance of our world was water, his student and associate Anaximander believed otherwise. Anaximander postulated that the world came from what he called apeiron, meaning boundless or infinite. It's not clear at this point what he meant by apeiron, but one possibility is that he was referring to an empty space that pervades the entire universe. Anaximander then postulated that the Earth had a shape of a proportionately short cylinder, as opposed to a flat disk, and that it floated in the apeiron. Hence, the sunrise paradox was also explained. Clearly, this was a progress, and Anaximander's model seemed to have been closer to reality than that of Thales. Anaximander's cosmos. Hence, this was the universe that we lived in, according to Anaximander. The Earth with a shape of a drum or millstone floating in some infinite space. Note that Anaximander's universe had the definite up and down orientation, and we Earthlings lived on the top surface of the drum-like Earth. We are floating in apeiron, an unknown medium that pervades the entire universe. This sounds funny, but the modern view is not much different. Chapter 8. Round Earth. Let's continue with our ancient cosmological models. Anaximander's drum-shaped Earth was eventually replaced by a spherical Earth. Pythagoras was one of the first philosophers who postulated that the Earth was round. By the time of Aristotle, it was well established among the Greek philosophers that the Earth had a spherical form. How do we know the Earth is round? So the shape of the Earth evolved from a flat disk to a drum-like shape and to a sphere. Many of Greek philosophers, including Pythagoras, postulated that the Earth was a sphere. It was no surprise since Pythagoras believed that sphere was a perfect shape. Pythagoras' philosophy profoundly influenced many later philosophers like Plato and Aristotle. As for the empirical evidence as to why the Earth was believed to have a spherical shape, or at least it was not flat, various Greek philosophers, such as Empedocles of Acragas and Anaxagoras of Clazomenae, came up with many different reasons which were later summarized by Aristotle. According to Aristotle, the moon was inferred to be spherical, based on the shapes of different phases, and it was natural to assume that the Earth was also round. Since the shadow of the Earth on the moon during a lunar eclipse was always round, the Earth must be spherical. As one traveled southward, the North Star, aka Polaris, was seen lower and lower in the sky, which could be explained by the downward curvature of the surface of the Earth. Aristotle himself also provided a philosophical reason that, since every portion of the Earth had a tendency to, potentially, move toward the center of the Earth, according to his physics, the Earth would eventually form a sphere, e.g., through compression. The power of reasoning. Aristotle laid the foundation for logic, e.g., deduction, syllogism, etc. One thing to note is that philosophy was for intellectuals or elites who had financial means. For most people, the Earth was still flat, and it was rather unlikely that most people even cared. The round and floating Earth. Ultimately, according to philosophers like Pythagoras, the world consisted of a heavenly sphere and the round Earth, which was considered the center of the universe. The only remaining question was, why does the Earth not fall? What keeps the Earth in place? Turtles all the way down. Where does the Earth stand on? Why doesn't the Earth fall? Is it supported by the proverbial turtle, which itself stands on the back of another turtle, ad infinitum? If not, how can the Earth be floating in space? The Earth at the center of the universe, as a possible answer? By taking the center of the Earth as the center of the universe, this conundrum of the floating Earth became no longer an issue, at least for the time being. This theory was later adopted by Aristotle as part of his cosmology. Obviously, we now know that we are not at the center of the universe. In fact, the universe does not have a center. By the time of Aristotle, the up and down directions as well as left and right are merely relative. The center of the universe. The concept of the center of the universe became an important part of cosmology. As part of a scientific argument, not as a religious doctrine. This becomes the doctrine that the humans are at the center of the universe when the Catholic Church adopted the Aristotelian physics. The center of the universe is now an obsolete concept, as many of the viewers may already know. We will discuss this further in later stories. But the idea of the center of the universe was an important part of the floating Earth cosmology for Greek philosophers. For example, Aristotle and later Ptolemy put the center of the universe at the center of the naturally round Earth, thereby avoiding the turtles all the way down problem. This was the dominant worldview for the following 1,000 years, comprising a set of concentric heavenly spheres, more than one, around the round Earth, whose center was the center of the universe. Then, in the 16th–17th centuries, an alternative model placing the Sun at the center of the universe was proposed, and the debate between heliocentric versus geocentric worlds essentially ended up giving rise to the scientific revolution. Chapter 9. Spinning Earth. We now discuss the discovery that the Earth is spinning. Now, let's move on to the next question regarding heavenly motions. Heavenly bodies' movement is regular. Why? Why don't the stars move around like billiard balls? Motions of heavenly bodies. What would have been like if the stars moved around like billiard balls every night? In fact, their motions are not only regular and extremely simple, but also eternal. They move in the exactly same way every night. For example, all heavenly bodies move in the same direction. More or less. Why? Clearly, the idea of heavenly spheres can explain this lack of freedom in the motions of heavenly bodies. But is it a good theory? The spinning Earth. The first philosopher who postulated that it was in fact the Earth that spun around its axis, and that it was not the heavenly sphere that made a daily rotation, was Heraclides of Ponticus, 4th century BC. Obviously, this is now a trivial, almost self-obvious knowledge at this point, which even a schoolchild knows, but it took almost 2,000 years before this was accepted as a fact. But there still seems to be a lesson to be learned. Theory A, where the heavenly bodies move around the Earth, has a lot more degrees of freedom, and hence it has to be constrained by imposing a heavenly sphere, which is rather arbitrary. Theory B, where the heavenly bodies appear moving because the Earth itself spins, is a much more restrictive theory. The two theories can explain the same phenomena equally well. But which do you think is a better theory? It was a minority view. The heliocentric worldview, including the rotating Earth, was only accepted at the beginning of the scientific revolution. Chapter 10. Moving Earth. Now let's move on to the next question. Is the Earth really at the center of the universe? Aristarchus of Samos. The next step in our evolution of the view of the world was to realize that the Earth was actually moving around the Sun and not the other way around. This was probably the most controversial theory, and it took over 1,000 years before it was accepted as a scientific fact. Aristarchus was one of the first Greek philosophers who postulated that it was the Earth that orbited around the Sun. In fact, he had a pretty comprehensive heliocentric model of the universe. The fixed stars remained stationary, and they were extremely far away. The Sun also remained fixed, and it was at the center of the universe. The Earth moved in a giant circular orbit around the Sun, due to the lack of parallax. The reason why Aristarchus hypothesized such a universe was because the Sun was presumed to be much bigger than the Earth. It was natural to suppose that a smaller body rotated around a bigger body, and not the other way around. There were a lot of twists and turns in the scientific progress, but this is indeed the most correct explanation in modern physics. Aristarchus was one of the greatest astronomers of Greece. Another of his biggest discoveries was the fact the Earth's axis precesses. He discovered that it precesses 1 degree per about 70 years by comparing his observations and the data available from ancient Babylonia. Copernicus, the rebel. These earlier ideas of spinning and moving Earth were, however, minority views, and they had been pretty much forgotten in history. The cosmology model of Aristotle and Ptolemy became, and remained to be, the standard model for the following 1,000 years. Then came Copernicus. He proposed a new heliocentric model of the solar system, which was alternative to the Ptolemaic model. It ultimately led to the start of the scientific revolution. It's not entirely clear why Copernicus came up with an alternative model of the world, despite the fact that the then standard Ptolemaic model was working just fine. Galileo's world. Finally, a complete story with all pieces together. It took almost 2,000 years to Galileo's heliocentric world. By the time of Galileo, this question of whether the Sun or the Earth is at the center of the universe became a legitimate and important debate among the intellectuals. Galileo was the first astronomer who used the then newly invented telescopes to observe the heavenly bodies, including the surface of the Moon, the Sun, and the moons of Jupiter. Galileo became a vocal proponent of the Copernican heliocentric worldview, which ultimately subjected him to the Catholic Church Inquisition. Galileo's paradox. If the Earth is circling around the Sun at an enormous speed, how come we do not notice it? This question led Galileo to his principle of relativity, which in turn guided Einstein to his special theory of relativity over 200 years later. We will address this question in later stories. Chapter 11. We are moving through space? So, we are floating in space and moving around at a high speed, which we claim to be the biggest discovery in our scientific history. What is space? So, we are floating in space and moving around at a high speed, which we claim to be the biggest discovery in our scientific history. So, what on earth is space? This is one of the most important questions that we will try to tackle throughout this series. Meanwhile, we hope that you are convinced that the universe is a mystery. Even such a basic fact that we are floating in space is a mystery, if you really think about it. In addition, there are a lot of fundamental questions that we don't really have answers to. What is time? What is motion? What is causality? And so on. Nutty questions. What are the important questions in physics, to you? Nutty people are the people who ask nutty questions, and not necessarily those who have nutty answers. Suppose that we can turn off gravity across the entire universe at a particular time in our reference frame. What will happen to the planets, stars, and galaxies? In our frame, as well as in other frames of reference? What makes Greek philosophy different from other intellectual efforts of the civilizations that preceded ancient Greece? What's next? In the next few lessons, we will go over some more big discoveries of ancient physics and mathematics, including the Pythagorean theorem and Euclidean geometry. We will also go through some basic mathematics, such as exponential and logarithm and trigonometry. Clearly, it is well beyond the scope of this series to review all essential mathematics, but to set the baseline for the viewers, we will lay down absolute minimal mathematics in the first dozen or so lessons. As emphasized in the series introduction, the lessons in this series are more of self-study guide than classroom lectures. Just to give some general ideas. Story 2, the question that started the philosophical revolution. Story 3, why do we live in the circular and spherical world? Story 4, the Pythagoras theorem is not about triangles. Story 5, the debate of century that shaped Greek natural philosophy.